Hey guys, welcome back. Today I brought a new method. Instead of teaching on a glass screen, I brought my iPad and I'm going to teach you math through this iPad using a digital notes. I hope I hope this method can also helps you understand better and more simpler. Um, I don't know, I'm not sure yet, but I wanted to try this another new method. Anyway, in this video, I want to think carefully about one idea, implicit differentiation. By the end, I hope this idea feels simpler and more connected. Before talking about formula, let's talk about uh, one question, like what is implicit differentiation? What does it mean? In single variable calculus, I assume you guys have learned about implicit differentiation. So we usually see functions written explicitly, like y equals f of x, right? This is explicit function. We can easily see y is depends on x. This means y is written directly in terms of x, so we can differentiate them normally. But sometimes the relationship between x and y is given implicitly, like such as x squared plus y squared is 25. This is an equation of a circle where the radius is 5, right? And the y term is not isolated. So it's not it's not a sort of form of y equals something. It's they get mixed, right? So it's called implicit function. And in this case, we cannot differentiate them like normally, like applying the rules that we have learned. So implicit differentiation is just a method that we use to find derivative of y with respect to x when y is not written as a function of x and when the equation mixes x and y together. So we want to find we want to find dy dx, and this measures how fast y changes when x changes. So we are still treating y depends on x even if it is implicit equation. Yeah, also you can interpret this equation as in this way too, dx of y, if this gives you more intuition. Another question that we can ask is also what does it really mean? What does it actually implicit differentiation mean? Even if the equation doesn't say y equals f of x, we still treat y as a function of x. So when we differentiate, remember that y depends on x, and remember we apply the chain rule whenever we differentiate a y term. So the important thing first, uh, y depends on x. Second, um, it's a we apply a chain rule, even though the function is not explicit. So these are the core idea. Um, so why do we need this? Why do we need implicit differentiation? Because many important curves are not written explicitly. For example, circles like x squared plus y squared is 25, or ellipses, hyperbolas, uh, physic physics constraints or like multivariable level curves, they are not an explicit function. Um, in real life, relationships are often constraints, not a function like explicit formulas. In geometric meaning, sorry. Suppose, let's say, suppose you have a multivariable function of x, y, and suppose it is 0. And as you can see, this defines a curve. Implicit differentiation lets us find the, the slope the slope of the tangent line by the way, sorry for my handwriting. um, it's not that easy to write it down while holding my iPad like this. And also, it lets us find uh, how the curve changes at a point. Implicit differentiation let us find these two things, even we never solve for y. So geometrically, implicit differentiation finds the slope of a curve defined by a relationship. Let's get into a deeper idea. Um, this is important. So in fact, implicit differentiation is really just a chain rule in disguise. What I mean is that let's say we have a multivariable function f of x and y of x, and we want to differentiate this function. So we want to find d dx of this f. As you can see, we need to apply the multivariable chain rule. As we have learned in the previous video, this is just partial x times dx plus partial y times dy dx. And as you can see, uh, this dx is simply just 1. More specifically, this is equal to d dx of x. And as you know, if derivative of a variable, any variable like x, y, anything else, is just 1. So we get an equation, partial x plus partial y times dy dx. Do you see something? We're almost there. And do you see where we are heading to? So we want to find dy dx, right? We want to find what dy dx is uh, in this equation. And we got dy dx, but just not isolated. So only thing we have to do here is just isolating the dy dx. Let me show you. So if you isolate this term, we want to isolate this, then we get the formula for the implicit differentiation. So in fact, dy dx is just negative partial x over positive, sorry, negative partial x over partial y. This is actually the formula for implicit differentiation. So this is the new method we can apply whenever we need to whenever we are given an implicit function. Remember, for example, in single variable calculus, let's say we are given a problem where it's saying um, find dy dx, where uh, x cubed minus y cubed is 8 times x times y. In single variable calculus, we had to apply like many rules, like differentiation rules we know to find dy dx, and it gets sometimes too complicated, right? Um, let me show you just for an example, like just for demonstrating. Let's say we wanted to find it, but we don't know the formula, so we can apply like the product rules or something else. So this is just, sorry, 3x uh, square minus 3y square is equal to 8xy. Oops, sorry, my bad. I forgot dy dx here. dy dx, which is, we need to apply the product rule, right? Yeah, the product rule. So this is just 8y plus 8 x dy dx, and we want to solve for this and this. So 3x squared minus 8y is 3y squared dy dx plus 8x dy dx. And this is just 3y squared plus 8x dy dx. And we want to isolate this term. So finally we get square minus 8y over 3y squared plus 8x is dy dx. And this is, not necessary. Nope, my bad. And this is how we get the dy dx. Before we knew the formula, but once now we know the formula, right? dy dx just simply negative partial x over partial y. So using new method, we can write our function as uh, f of x, y is 0. So using the same example, apply the rule for the same example here. Oh my god, what I'm doing? Right here. This is just simply, let me use the blue pen, x cubed minus y cubed minus 8xy, let it becomes 0. And using the multivariable chain rule, we know the formula. Yep. So dy dx, we can easily see is negative 3x squared minus 8y over 3y squared minus 8x. We get the same answer. So what it means is that this formula works. If I draw a tree diagram to see the dependence, I can say on the top there's a z, x, y, and x, and x. Something like this. And this can be any variables, but I just said x, and we find dx here, and here we find dz dx, which is a partial x, and here dz dy, which is partial y, and here is dy dx. I hope this finds you more, helps you more, building more intuition. Yeah, that's it. That's actually it for today's video.